Well, so we are doing numericals on dual nature, and we have done it earlier. The photoelectric equation, this is for the frequency and this is for the wavelength, and the kinetic energy, that is can be written as E into Vs. Vs is the stopping potential, and this part is for matter wave de Broglie wavelength of any matter is h by p. H is the Planck's constant and p is the momentum. And it can also be written as p momentum can be written as root over of twice mk, where k is the kinetic energy. Whenever you accelerate a charged particle across a potential difference, the charged particle moves with a very high speed. Then that charged particle will also get associated with a wavelength. So if you need to find out that wavelength, in case of kinetic energy, we use the potential energy across which the charged particle has been accelerated. That's why in case of k, we get q into v. So if you want to find out the wavelength of a charged particle when accelerated across a potential difference v, then that will be lambda equal to h by root over of twice mq into v. Alright? Now let's quickly try out the sums. First question is what? See this formula, it is actually this can also be written as h mu equal to phi plus half mv square. Remember what is phi? Phi is the work function. So work function is h mu naught. This work function is h mu naught. H is the Planck's constant and mu naught is the threshold frequency. Alright? Now, the first question says the maximum kinetic energy of photoelectrons emitted by a surface when protons of energy 6 eV falls on it is 4 eV. Means incident energy is equal to 6 eV. Achha, do you know what is eV? Did I discuss about eV? 1 eV is the potential energy or energy of a charged particle when an electron is accelerated across a potential difference of 1 volt. So the formula is E into V. In case of Q, we'll have E. So E is 1.6 into 10 to the power minus 19, or V is 1. So this is 1.6 into 10 to the power minus 19 joules. Clear? 1 eV is 1.6 into 10 to the power minus 19 joules. You don't need to always convert this, but if you have a sum where other expressions are associated, then you might need to convert this. अब यहाँ पर incident energy of the photoelectrons बोला हुआ है 6 eV, and the maximum kinetic energy, that means this expression में ये वाला expression, ये वाला part, the maximum kinetic energy is equal to 4 eV. It is given. Now they are asking what is the stopping potential for the fastest electrons. So actually this is useless over here. ये कोई use यहाँ पर नहीं होगा, क्योंकि हम तो सेकंड वाला फॉर्मूला से करेंगे कि half mv square equal to E into Vs होता है. So half mv square is E into Vs. So that means E into Vs is equal to half mv square का kinetic energy का expression क्या है? 4 eV, right? अब 4 eV है, तो दोनों साइड से अगर हम लोग E को कैंसिल आउट कर देंगे तो Vs क्या मिलेगा? 4. So the potential difference across which it has to be accelerated is 4 volt. Is that clear? जल्दी से बना लो and then I'll do the next one. Okay, question number 2 में बोला है that two metals X and Y when illuminated with appropriate radiation emit photoelectrons. The work function of X is higher than Y. Which metal will have higher value of threshold frequency? Now, work function का formula क्या है? ये phi जो है ये h mu naught है. Look at this. ये h mu naught भी क्या है? ये phi है. ठीक है? So phi is the work function and mu naught is the threshold frequency. ये क्या है? ये है work function and this mu naught is the threshold frequency. Okay, so what you do over here, यहाँ पर पूछा गया है x और y में the work function of x is higher than y, मतलब phi x is greater than phi y. So which one will have higher threshold frequency? Simple phi x equal to h mu naught x, and that will be greater than h mu naught y. So दोनों साइड से if we cancel off h, then mu naught x has to be greater than mu naught y. that clear? U naught x is vastly greater than U naught y. Now 3. Question number 3. What is the energy associated in joule with a photon of wavelength 4000 Armstrong? So photon concept, according to the photon theory, the energy associated with the wavelength is given by hc by lambda, right? So just हम लोग को hc by lambda use करना है. Planck's constant का value कितना है? 6.625 10 to the power 34. So this into 3 into 10 to the power 8 divided by wavelength is how much? 4000. Now answer we have to convert it in meters 10 to the power minus 10. ठीक है? So evaluate करने से जो आंसर आएगा that will be our answer. Question number 4. Why does the existence of cutoff frequency in the photoelectric effect favor the particle theory of light rather than wave theory? क्या करेंगे इसका आंसर क्या लिखेंगे? This is a conceptual question. It says that why does the cutoff frequency का मतलब क्या? What is cutoff frequency? This threshold frequency is also called cutoff frequency. So what is the use of this cutoff frequency? Cutoff frequency का use क्या है? हाँ, but why can't the wave theory explain it? Why do we need the particle theory for its explanation? Because according to wave theory, it should take a lot of time for all the electrons to reach that much amount of energy so that it can escape the metal surface. But in actual photoelectricity, we have seen that it is an instantaneous process which cannot be explained on the basis of cutoff frequency. So, according to wave theory, any frequency of light, if given for sufficient amount of time, will produce enough energy to pluck the electrons out of the metal surface. But in photoelectricity, we are seeing that below a certain frequency radiation, there is no electrons being emitted from the metal surface. Hence, particle theory is applicable, not the wave theory. Okay. So what do you need to write? Just write this down. Right? According to wave theory, frequency of any radiation, according to wave theory, frequency of any radiation can you change the words? Radiation of any frequency. Radiation of any frequency, if allowed for sufficient amount of time, then the electrons can have enough energy to eject photoelectrons. But in actual process, below a certain frequency called cutoff frequency, no radiation, no photoelectric emission takes place. No photoelectric emission takes place. Hence, the requirement of particle flow. Hence the requirement of particle flow. Clear? हो गया सब लोगों का? Now, question number 5. क्या बोल रहे हैं? It says aluminium and calcium have photoelectric work functions of given. So, work function of aluminium is 4.28 eV and work function of calcium is 2.87 eV respectively. Which metal requires higher frequency light to produce photoelectrons? Of course, work function जिसका ज़्यादा होगा उसका threshold frequency भी ज़्यादा है, ठीक है? Threshold frequency भी ज़्यादा है. So obviously, first part, since phi AL is greater than phi CA, that implies mu naught for AL should be greater than mu naught for CA. Alright? So which metal requires higher? So answer is aluminium. Aluminium requires higher frequency. Requires higher frequency. Second, higher frequency radiation. Second part, find out the minimum frequency that will produce photoelectrons from each surface. So you need to find out these mu naught and mu naught CA. Right. So we know phi equal to H into mu naught, means mu naught equal to phi by H. Alright. So phi by H if we do for aluminium, therefore mu naught AL equal to phi of AL. Phi of AL is how much? 4.28. Okay. But the answer, question is given in EV, right? So whenever it is given in EV, you need to get it converted into joules. So that will be 1.6 into 10 to the power minus 90 divided by H. Planck's constant is 6.65 into 10 to the power, sorry, 6.625 into 10 to the power minus 30. Right? So this will be mu naught for frequency for aluminium and frequency for calcium will be same expression, only work function will be 2.87 into 1.6 into 10 to the power minus 19 divided by 6.625 into 10 to the power minus 34. Okay, the answers are given in the assignment. Solve them and match the answers and see whether they are coming out to be correct or incorrect. Okay, it's very important. Question number 5 done. जल्दी से बताओ हो जाने से quickly. Okay, now see next question is question number 6. It's a question on general knowledge basically. So or you can say common sense. How many photoelectrons per second does a 1 watt bulb emit if its efficiency is 10% and wavelength of light emitted is 500 nanometer? So what we need to understand is that how many photons, oh sorry, I'm just reading it out wrong. It's not photoelectrons, how many photons? Okay. So now you know that efficiency क्या होता है? What is efficiency? Output energy by input या output power by input power. ठीक है? Input power. Efficiency 10% बोला हुआ है. So 10 by 100 equal to output power by input power कितना है? 1 watt दिया हुआ है. Input power is given to be 1 watt. So therefore output power कितना निकला? 0.1 watt. आया. अब बोल रहे हैं कि how many electrons per second are ejected. So therefore if this is power, then energy per second is also this. Yes or no? Because power is defined as rate of doing what? That is energy by time. आया ना? तो watt क्या है? Joule per second है ना? So can I say that energy per second energy per second is 0.1 joule, right? अब ये जो photons निकल रहे हैं उन लोगों का wavelength कितना दिया हुआ है? Energy of each photon is equal to h into c by lambda. आया ना? फोटोन का एनर्जी h by lambda होता है. अब h का प्लैंक्स कांस्टेंट कितना? 6.625 into 10 to the power minus 34. c is 3 into 10 to the power 8 और यहाँ पर वेवलेंथ कितना दिया हुआ है? 500 नैनोमीटर. Means 500 into 10 to the power. Yes or no? ये हो गया. अब हम लोगों को क्या करना है? This is the energy of each photon. एक फोटोन का एनर्जी है. So if we wish to find out what number of photons, so this is the total energy and this is the energy of each photon in joules. So multiply करेंगे. Number of photons emitted per second is equal to this divided by this. So it will be 0.1 divided by 6.625 into 10 to the power minus 34 into 3 into 10 to the power 8 into 500 into 10 to the power minus 1. Right? This is question number 6. जल्दी से बना लो. So the next question, question number 7, it says the radiation of wavelength 500 angstrom. So lambda is equal to 5,000. So that is 5,000 into 10 to the power minus 10 meter. Is incident on a surface of work function. Work function means phi. Phi is equal to 1.2 eV. They are asking you to find out the stopping potential. Stopping potential निकालना है हम लोगों को. तो what formula will you use? hc by lambda is equal to phi plus e into ps. अब तुम बोलोगे सर ये फॉर्मूला तो नहीं लिखा, कैसे ये फॉर्मूला लेके आ गए? कुछ भी नहीं, देखो यही फॉर्मूला है. दिस इज द फॉर्मूला. ओके, ये फॉर्मूला ही ये है. क्यों? hc by lambda है. ये वाला पोर्शन क्या होता है? वर्क फंक्शन. That is the minimum energy required. So वो वर्क फंक्शन है, मतलब ये वर्क फंक्शन हो गया. और लास्ट में हाफ mv स्क्वायर ही तो क्या होता है? EVS. So we can write plus EVS. Is that clear? अब प्रॉब्लम ये है कि यहाँ पर एक जो चीज दिया हुआ है 1.2 EV में दिया हुआ है. So it will be better if you find out this in EV. ये वाला चीज अगर EV में निकालोगे तब सम करने में बहुत इजी होगा. क्यों? क्योंकि अगर EV में होगा तो VS डायरेक्टली निकल जाएगा, क्योंकि E सब में कॉमन होगा, कैंसिल हो जाएगा और VS डायरेक्टली निकल जाएगा. ओके, सो व्हेनेवर इट इज गिवन आस्क यू टू फाइंड आउट द स्टॉपिंग पोटेंशियल, याद रखना EV में काम करना है, इलेक्ट्रॉन वोल्ट में काम करना है. इलेक्ट्रॉन वोल्ट में काम करने से क्या होता है? सॉल्विंग इजी हो जाता है. ठीक है, एक पार्ट कैलकुलेट करने में थोड़ा डिफिकल्टी होता है. देयरफॉर hc by lambda, h क्या है? 6.625 into 10 to the power minus and c is 3 into 10 to the power 8 divided by wavelength. How much is the wavelength? 500. 5000 into 10 to the power minus 10. 5000 है 100. और एक इम्पोर्टेंट चीज है, ये जो आंसर आया इसका आंसर यूनिट क्या होगा? ना राइट, दिस मच जूल्स. तो इसको EV में हम लोगों को कन्वर्ट करना है. तो 6.625 into 10 to the power minus 34 into 3 into 10 to the power 8 by 5000 into 10 to the power minus 10 into 1.6 minus 19. This much EV. ठीक है, divide by 1.6 into 10 to the power minus 19 will get converted into electron volt. Yes or no? Is that clear? अब हम लोग क्या करेंगे, ये जो EV आएगा ये यहाँ पर पुट करेंगे. फाई का वैल्यू मालूम है तो EVS निकल जाएगा, और EVS निकल जाएगा तो दोनों साइड से E कैंसिल कर देंगे तो VS निकल जाएगा. Will you be able to do it? Yes or no? कर पाएंगे हम लोग? However, so solve it and the answer is given. Match the answer and tell me whether it is you are getting the answer or not. ठीक है? Next question. So see, when we calculate this part AC by lambda, it comes out to be 2.48 eV. Alright. Now if we put back this value over here, this is 2.48 eV is equal to phi is how much? 1.2 eV plus EVS. So if you bring this on the left hand side, it will be 2.48 minus 1.2. So kata hobe 1.28 EV equal to EVS. So you can cancel out the E from both sides. So VS equal to 1.28. Clear? You can calculate 10 to the power plus 3 plus 3 or minus 3. Well, question number 8. So it says when light of frequency, see it says that when a light of frequency of 547.5 terahertz illuminates a metal surface, the most energetic photoelectrons have 1.26 into 10 to the minus 19 joules of kinetic energy. And the same metal surface, when illuminated by 738.8 terahertz frequency, the kinetic energy of the electrons becomes 2.48 into 10 to the power minus 19 joules. What I need to find out is the Planck's constant from these two equations. So what we'll do, we'll use this h nu naught equal to h nu plus half mv square. Okay, this formula twice and then solve it to find out h. So for the first expression it is h into 547.5 into 10 to the power 12, right? Plus half mv square is 1.26 into 10 to the power minus 90. Frame the second equation. In the second situation, it is this equation 1, and the second equation is h into 738.8 into 10 to the power equal to 5 plus 2.48 into 10 to the power minus 9. This equation 2. So you need to find out h from these two equations. So it's very simple. You can subtract the two equations. 5 will get cancelled and you get the value of h. So the value of h will be, solving 1 and 2, h is equal to 2.48 minus 1.26 into 10 to the power minus 19 divided by 738.8 minus 547.5 into 10 to the power 12. That will give you the value of Planck's constant. Okay? Okay, now the next question, question number 9. It's a theoretical question. It says that predict and explain light of a particular frequency particular wavelength does not eject electrons from the surface of a given metal. Now they are giving the question as, should the wavelength of light be increased or decreased in order to make the ejection of electrons possible? So you can see this, the energy of incident light is inversely proportional to the wavelength. So if a particular wavelength cannot make the ejection, that means we have to reduce the wavelength to increase the energy of the incident. Okay, so they are inversely proportional. So obviously the answer will be lambda should be decreased, means wavelength should be decreased. First, wavelength should be decreased. Wavelength should be decreased. Now, second, it says that choose the best expansion from the following. The energy of a photon is proportional to its frequency. That is inversely proportional to wavelength. To increase the energy of the photons so they can eject electrons, one must decrease their wavelength. And option B is the photons have too little energy to eject electrons. To increase their energy, the wavelength should be increased. Obviously, option A is the correct answer. A is the correct answer. Clear? Now they are saying question number 10. They are asking you to plot. Question number 10. They are asking you to plot a graph showing the variation of stopping potential with frequency of incident radiation for two different photosensitive materials having work functions W1 and W2, where W1 is greater than W2. On what factors does the slope and the intercept of lines depend? So first you have to draw the graph. So obviously we'll have two graphs. Remember, for different metals, the graph may start from different points, but they have to be always parallel to each other. You know why? The graphs has to be always parallel to each other. This is the Vs versus frequency graph. Stopping potential versus incident frequency graph. Why should they be parallel, always parallel to each other? क्योंकि स्लोप जो है वो प्लैंक्स कांस्टेंट डिनोट करता है, तो प्लैंक्स कांस्टेंट एक कांस्टेंट क्वांटिटी है ना, वो चेंज नहीं करता है, ठीक है। सो एक्चुअली प्लैंक्स कांस्टेंट नहीं डिनोट करता है, प्लैंक्स कांस्टेंट बाय ई डिनोट करता है। तो इसीलिए दोनों का स्लोप ऑलवेज सेम होगा, मतलब दे विल बी ऑलवेज पैरेलल। अब मुझे बताओ कौन सा W1 है, कौन सा W2 है? कौन सा W1, कौन सा W2 है? फर्स्ट वाला। कितना जोर का थप्पड़ खाना है? क्या दिया हुआ है? कौन किसका वर्क फंक्शन ज्यादा दिया हुआ है? W1 ज्यादा वर्क फंक्शन है ना, ज्यादा वर्क फंक्शन में तो उसका थ्रेशोल्ड फ्रीक्वेंसी भी ज्यादा होना चाहिए। ये न्यू नॉट 1 है, ये न्यू नॉट 2 है, तो ऑब्वियसली ये W1 का होना चाहिए और ये W2 का होना चाहिए। Why? Because it is mentioned that W1 is greater than, clear? हाँ यार, और उसके बाद क्या बोला हुआ है? स्ट्रेट लाइन होगा, स्ट्रेट लाइन कर्व नहीं होगा। हाँ ठीक है, स्ट्रेट लाइन। नेक्स्ट, on what factors does the slope and the intercept of the lines depend? स्लोप और इंटरसेप्ट किसके ऊपर डिपेंड करेगा? हाँ, स्लोप डिपेंड्स ऑन Planck's constant. Planck's constant and intercept depends on threshold frequency. Intercept depends on threshold frequency. ये ऑप्शन 1 है, पार्ट 1 और ये पार्ट 2 है।
सकता है राइट?
अच्छा, नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 11. The question number 11 says, suppose the wavelength of light incident increases from 300 angstrom to 3040 angstrom. Find the corresponding change in its potential. So wavelength के साथ स्टॉपिंग पोटेंशियल एसोसिएटेड होता है ये वाला फॉर्मूला में, राइट? सो फर्स्ट इक्वेशन बनेगा hc by lambda 1, lambda 1 is 3000 angstrom, okay? 3000 is equal to 5 plus BVS1, ये इक्वेशन 1 है, और hc by 3040 is equal to 5 plus EVS2. Okay? So therefore, if I subtract the two equations, VS1 minus VS2 will be equal to hc taken common 1 by 30 minus 1 by 3040, right? So they want you to find out this one, the difference in stopping potential का difference. लेकिन वो बोर्ड पे आंसर दिया हुआ है, तो इसलिए ये वाला एक्सप्रेशन को हम लोगों को बोर्ड पे लाने के लिए h is 6.65625 into 10 to the power minus 34 10 to the power 8, और इधर तो 3040 minus 3000 by 3040 3000 into 3040 आ जाएगा। अगर हम लोग सिंपली कर लेंगे, डिवाइडेड बाय 1.6 into 10 to the power minus 19 कर रहे हैं ताकि ये किसमें आए, ईवी में आए। ठीक है, तो सॉरी यहाँ पर ई रहेगा, ई रहेगा राइट। तो लास्ट में ईवी दोनों से ई कैंसिल कर देना है, तो VS1 minus VS2 बन जाएगा। समझ में आया? क्या प्रॉब्लम है? जल्द से लिखना चालू करो। गुड जॉब, गुड जॉब।